Hey, everybody. This is Fernando Labastida with Jimmy Jobe, CEO and co-founder of Verge Technologies, once again in another episode of the Converge Cloud podcast. And offline, Jimmy and I were talking about something that was very interesting. I think a lot of what informs your point of view and the philosophy that led you to start Verge Technologies were kind of forged in that fire that was when you were working with HP, right? And some of your experience. I was wondering if you could tell us that story and how that shaped your thinking about cloud migrations and cloud data.
Yes, I'd be glad to. Yeah, thank you, Fernando. Yes, I ended up consulting for about 4 years with HP Enterprise. And during that time, the task at hand was data center consolidation, right? And this wasn't really even a consolidation or a migration from, say, one cloud provider to another, like, say, AWS to Azure, right? Or to Google. This was about consolidating data centers, even within one proprietary cloud within HP's cloud, right? So this was brought about by old EDS data centers that needed to be decommissioned and needed to move people from those older data centers into some of HP's new state of the art data centers. And so that meant migration of very large enterprise accounts from one location across the United States to another location, right? So with each one of those moves, there was a tremendous amount of planning, both from the teams that were in the source data centers and the target data centers, and teams that would plan and take inventory and decide what goes first, what goes second, what has latency issues with it that wouldn't allow it to be moved at this time. And so you had to sequence everything in a certain way in order to make those moves. And this included both mainframe as well as what I would call mid-range or client server. So it was everything had to come out of those data centers. And so a lot of those lessons were painful in the fact that large maintenance windows would have to be set up. And within those maintenance windows, you would, full backup plans were always developed so that, if anything goes wrong, you can revert back to the way it was and, we'd try again later. And that happened, of course, on numerous occasions as it often does, right? And so we would start let's say a database migration. And so first of all, you entered in the maintenance window and you started shutting off the stream, right? Or diverting the stream to another source if it couldn't go down, like a failover stream. And so cutting off access and then waiting for the existing transactions that were in flight to finish processing and bleed off, if you would. And then once that kind of got down to a minimal state, then it was about then trying to copy that database from one location to the other location, right? And then making sure that you've moved the application over and stood it up. Applications are much different to move than databases because they're typically not stateful. You can go and set them up above time and provision them and turn them up. A database is a stateful being, and if you're going to have 100% transaction consistency, you have to really focus on how you do that, right? So we would then copy over, move, turn up the database, turn up the applications, then go through the long process of syncing the applications back to the database that we had moved and making sure everything was up and running, and then watching that for long periods of time to make sure there wasn't any hiccups or it didn't go down again after 30 minutes or whatever. And so it was a very long ordeal, and it made me start thinking that there had to be an easier way to move a stateful machine, a stateful processing environment from one location to the other without all the excessive downtime, without all the brain damage of all the planning and everything else. In other words, provide an automated mechanism that was intelligent enough to take in consideration all the different connections to that database, all the things that were going on in that database, and be able to move that database from point A to point B, in a live environment, not taking any downtime, and still do that 100% reliable and 100% transaction consistency.
Mhm.
So that was kind of on our minds when we started Verge Technologies. That and the fact that enterprises were by definition entering into multi-cloud environments, whether they liked it or not, right? People were moving to cloud services because those cloud services offered them commodity infrastructure, commodity services at, quote, a lower price, right? And so they were getting hammered. Every IT dollar was getting hammered, and they thought and they believed this was the outlet. And I got to say, this is not a knock against cloud service providers. They provide a very useful service, right? It a hosting service that can probably host your environments cheaper than what you could provide the labor to do it, right?
Yourself, yeah.
And so, but by doing that, it exposed a lot of other issues in the enterprise that the cloud providers couldn't solve, right? So, for example, if you have legacy applications and legacy databases that the architecture won't allow you to run in the cloud, right? In the cloud environment, then those have to stay in your proprietary data centers, right? And so by by moving parts to the cloud, it still left parts somewhere else, right? So you, by definition, started running in what I'm going to call a hybrid cloud or multi-cloud environment. It's just that each one of those environments was in its own sphere, right? It had its own tools, it had its own SLAs, it had its own networks, and so you then were trying to run your operations across both of those environments and ensuring that your operations were unencumbered, right? That they could operate as easily as they did before. Well, that's a very tall order because they're not under the same management, they're not under the same control, they're not under the same SLAs, they're not under the same anything, right? So it becomes a very challenging task. And there were other reasons that kind of compounded not only the legacy apps and databases, but there was always the security element, right? There was the fact that if you had a distributed footprint in your enterprise, there wasn't a ubiquitous service provider, let's say like an AWS or a Google or an Azure or an Oracle on every street corner where you happen to have a footprint, right?
Right.
So you ended up having to select other service providers on a regional and local basis, and then turning up the portion of your processing that needed to be done there and try to figure out how to get that data and those databases synced up with your central processing in order to run your enterprise, right? And so the more that happened, the more complex that became, right? Of getting data where you needed it and being able to be transparent across all those particular computer cloud environments so that you could reliably and consistently try to manage your enterprise. And Fernando, that turned out to be very difficult. And it's difficult today, right? So that is the reason we built our intelligent IT management products at Verge to order to solve what I'm going to call a cloud convergence problem, right? As today, every single one of those individual cloud providers or compute environments, if you have a proprietary data center, has management tools where you can manage vertically within their cloud, right? But the Azures or the AWSs of the world are never going to manage the database assets, for example, that are in a competitor's environment, right? The people in AWS are not going to manage the database assets of an enterprise that happen to be in Azure and vice versa, right? So they become, if you would, computing silos that can be managed vertically with different tool sets that are available in different service providers. typically those tool sets are not integrated. In other words, there's ability to migrate or to replicate or to scale or to do different things around a database, but there's no glue that integrates them all together. There's no glue that automates all of that around the managing the health and well-being of a database.
Yeah.
It's just, if you need this tool, I can provide this tool, but of course that tool is a la carte and it costs, right? When you do this, right? So at Verge, we decided to build a product called SentientDB that basically had all of that tool set, if you would, in an integrated platform that used AI to predict workload issues and then to take action for those workload issues before they happen. So, in other words, to not be in strictly a reactive role, although we can do that, but be in a proactive role where it doesn't ever get bad enough to present itself as an outage or to present itself as a performance or accessibility issue, that we can intervene and solve the problem, mitigate the problem, resolve the problem, eliminate the problem before it happens, right? So, and not only do we do that for the vertical management within a particular environment, but we do that horizontally across different environments. And so, between those two planes of management integrated together, you get what I'm going to call a holistic or federated management view that allows you to manage assets everywhere across your enterprise footprint. We provide that fabric that goes across your enterprise footprints and allows you to manage, to move, to provide mobility, to provide performance improvements for those assets, no matter where they are on the globe, as a matter of fact.
And then so you talked about AI being able to so the AI part of SentientDB being able to predict loads before it becomes a problem, and then also being able to, providing a fabric that allows you to manage across these different clouds. What kind of to give us a little bit of a under the hood view as to those technologies? I mean, are you using predictive analytics or for the AI aspect of it, or and then for the cross cloud fabric? I mean, help us understand a little bit about what technology was involved with this.
Yeah, and so our platform, like say, it automates database management, right? So all of the tools you can think of that help you migrate, cluster, scale out, scale in, replicate, backup, all of those are integrated in one platform and automated. And then we use AI to provide the intelligent management insight, if you would, about each one of the workloads that database is processing, right? So our platform, if I had to break it down, I'd break it down into three parts, right? We have, first of all, a very, very good monitoring tool, right? A monitoring platform that monitors the health and well-being and all the critical attributes of the database itself and of the server and the operating system. So we know the hosting environment's health. We know that server, how much CPU utilization, how much memory it's all consuming. We also are monitoring all the critical performance attributes of the database itself, right? And we're taking all of that data, we're monitoring it, we're trending it, and we're predicting outcomes. And so that's where the predictive analytics and some of the AI come in, is being able to predict a workload issue down the path so that you still have time to react to it before it becomes critical to stopping the processing of that workload. I'll give a small example and then I'll go to the kind of the second part, right? A small example of that might be if you have a virtual server and towards VM, you could have numerous applications and numerous databases operating on that machine. So all of that together is really forcing that database to operate at a less than an efficient, optimized performance, right? So memory utilization, let's say, is starting to climb. It's 60, it's 70, it's 80, it's 90% memory utilization. And so you know that if that keeps moving in that direction, that in another 12 minutes, you're going to run off the rails and things are going to saturate and start backing up, and you're not going to be able to process, right? So, what we do is by monitoring that particular attribute, then we can take action to then pick that database up and move it to a larger server. We could split the workload of that database across multiple servers, of which you would cluster it out, right? Add to it, scale out. And then if that backlog or that resource contention issue of that server began to ease, then we could back off those instances and scale back in till we're just operating back on that server. By doing this, it allows us to start to take the action we need. Do we know what action that needs to be taken? The second part of our product is what I'm going to call a very powerful policy engine, which allows us to invoke policies to do actions.
Mhm.
So in this case, what we would do is say, look, if memory utilization is above 85% for the next 5 minutes, I want you to pick this database up and I want you to move it to a larger server or move it to a different network that's less congested or split the workload. Whatever the action that the operations team is decided, that's invoked in a policy, right? And then the third element is we do use container technology to then pick up that database and move it. It's an object. We pick it up and move it from A to B, right? So essentially those three elements integrated together in an automated platform is what we use to manage both vertically and horizontally and create a visual representation of everything that you have across your enterprise footprint managed by a single fabric and a single console and allowing you to take action before it becomes critical.
Yeah. I mean, that sounds so innovative. It sounds like as though it was like, why hasn't somebody come up with that before? You know?
Yeah, I think, I think people are getting there. We are the first in market with what I'm going to call cloud convergence. And what we mean by cloud convergence is managing many clouds as one cloud, right? That federated view of all the, let's say, the database or application assets in your enterprise footprint at your fingertips. You know how they're all running, they're in AWS or proprietary data center or Oracle or Google or wherever they're at. We know how they're running. We know what the performance level is. We know how they're managing workloads, and we can take action to optimize the performance of any one of those depending upon the workload issues that it's having, right? So we built our product with that in mind.
Well, so changing gears a little bit, Jimmy, I was wondering if you could get into a little bit about the difference between this startup that this is the fifth startup you have
Yes.
been involved with, right? And so I was wondering if you can get into a little bit about the difference between this startup and some of the previous startups that you have been involved with as founder, co-founder, CEO, CIO, what have you.
Right, right. So that's a very interesting topic. Yeah, wish we had a beer or two to go with it, but it's a little early, right?
It's a little
So
early in the morning for that, but it's 5
yeah,
o'clock somewhere.
so yes, I've been involved in about five different startups over the last 20 plus years, right? And those startups, about half of them were VC funded or private equity funded, and the other half were just startups. I mean, just, bootstrap, let's get it out kind of thing. One of those was a service company. Actually, two of those were a service company, and three of those were product companies. And so the complexity is much different. The mindset is different in a service company versus a product company, right? The margins are wildly different, right?
Yes.
So those VC funded enterprises allowed you to, of course, have a a cushion that would allow you to have the right staff to get the right product to the market to meet a specific problem. And so, with that comes, a lot of oversight, a lot of second guessing. With that comes, kind of the elimination of the people that were really starting the company as a primary stakeholders, right? Because that investment from the VCs comes at a price, right?
Yes.
And so, but the good side of that is it really does provide a support mechanism underneath that allows you to execute and do the best job that you can under all of those conditions, right? So it's a good model. It's probably not for everyone. It depends upon uh, fit of the product. It depends upon the risk factors that the VCs are wanting to take, and how far out in the do they want a product that kind of globs on to an existing uh, issue and provides a also played kind of atmosphere, or are they risk takers? Are they people that see the future in the same way you see the future and are willing to invest in that to hit a particular market that might still be 18 months or 2 years out? So there's a lot of factors that go into that. Where if you're just bootstrapping and right, you've got a second or third job, or you're willing to put your mortgage on the line, or any of those other things that you're tied together with your partners as brothers, right? And you are pushing all toward a common goal. And you all bring very specific skills in order to create a product that fits and solves several industry problems.
Yeah. Yeah, and so that's that, what you just ended with right there is kinda like transitioning into how you're doing things right now with Verge, right? You're not totally bootstrapped because you do have investment, but it's not a VC level investment. I would say it's kinda more friends and family or angel type investment, etcetera. So tell me a little bit about the dynamic with running Verge, you know, compared to sort of like that support that you got with a VC funded startup, as well as kind of like the baggage that comes along with it, and kind of like maybe the lack of autonomy that you have
Right.
with a VC. Yeah.
Yeah. Our funding that we've needed in order to get to where we are, right, has come from friends and family. We've not taken any institutional money as of this date. We also don't have any debt, right? So the VCs, if they're putting in money, they're seeing a future. So everybody's impatient, but they have a little longer game plan usually. Friends and family, they will take a greater risk, I guess my experience has been, but they really want to see the payoff sooner because they got their family money in it and they want it out, right?
Yeah. Yeah.
So there's pluses and minuses to both those approaches. I really like what we've got accomplished at Verge. I really do appreciate the shareholders and their patience as we have unfolded this. We were probably a little early to the market because of just the fact that this multi-cloud, hybrid cloud management has really in the last 5 or 6 years started to manifest itself in the fact that, even now Gartner is saying, the average enterprise has between 4 and 7 different service providers to cover their operations and their distributed footprint, right? So, and, enterprises don't really like the idea of putting kind of all their eggs in one basket, like trying to get all in AWS or all in Google, right?
Right.
Because they understand intuitively that that comes with a price, that comes with a lock-in price, right? Lock in with services, lock in with relative to cost increases, lock in relative to less leverage in trying to make new deals with that service provider, right? And so intuitively, they would rather not do that, even though they are sometimes forced. In the beginning, That was kind of the mantra, get all in. But we all know that that didn't work out, and it didn't work out for even the people that did it very
Yeah.
well.
Yeah. Yeah. So, and so it's interesting because you started Verge because you saw that dynamic happening, harkening back to what we talked about earlier, the stuff that was going on with HP and EDS, but then also, I think that data point that you mentioned is really interesting, that enterprises typically have 4 to 7 are you talking about cloud providers?
Yeah, there are different service providers. Now, some of those 4 to 7 could be proprietary data centers that they've already had, and some of those could be different cloud providers, right? So, especially that is true once you step your foot off in the water outside the coastal boundaries of the US, right? If you go to Europe, for example, there's certainly not an AWS on every street corner. And as of a couple of years ago, I don't know if it's changed. There wasn't an AWS at all in like Italy, right? There was one in Amsterdam, right? And so if you had business in Italy, you had to turn up somebody else typically, and then they had to interface, and you had to figure out how to get your data back there, right? And so one of the issues that caused, especially in Europe, is the fact that their privacy, their data residency, data location laws that are there says that if that customer data was made in Italy, it needs to stay in Italy. Or it needs to stay in Germany or wherever, right? And so it can't go to Amsterdam. We don't want it in Amsterdam. We want it in Italy, right? So being able to provide data location, data residency, which we can do with Verge, right, and SentientDB, just to assure that your data that's being processed there and managed in Italy stays in Italy, right? And so again, once you start moving around the world, chances are the ubiquitous service provider kind of goes out the window because they're just not available everywhere you have your footprint.
Yeah. Yeah. Wow. That's great. Now, and those kind of laws are really kind of more particular to the European Union, but I don't know if they apply to any parts of the United States or in Asia as well, keeping data within a
Yeah.
certain geographic area.
Right. So a little bit less so. In the US, we don't have those specific ones, but we have other standards like HIPAA and different things that, in the credit card data, PCI data,
Mhm.
that has to be handled and managed in certain ways. So, and then financial data, while we don't have those laws, most of the financial institutions understand the privacy and where that data is stored is important, right? And how it's stored, right? And once you put it in the cloud providers are going to determine where that data is stored. They're going to determine the most economic and the best location for that data, and they're going to put it there, no matter whether you want it outside the U.S. or not. That just by how they store it, it's going to end up somewhere else, right?
Right. But then with SentientDB and with what you're trying to do, you can somewhat control that, right? So you can,
We
yeah.
can. It's interesting. We solved kind of that issue by solving another issue, right?
Mhm.
And that being latency. So latency between, let's say, the application and the database. They got to be in close proximity, or they don't have to be in close proximity, say, right, of each other. And so by controlling where that database is and controlling how we manage that database, we can also control the latency, right? But because we can do that, we can also control the location of that database relative to residency and location laws.
Gotcha. Gotcha. So that way you're a solution to the HIPAAs and the PCI policies.
Yeah, if they want the data or the financial data, and wherever the enterprise wants that data to be and wherever they want that data to stay, whether there's laws or not, we can help them manage that.
Okay, that's fantastic. Well, listen, Jimmy, this has been really one of the more interesting interviews that we've had, and I think we're going to be meeting it together again in another couple of weeks with another really interesting, action-packed episode.
I'm looking
About
forward to it. It's great to talk about the changes that are happening out there and why they're happening.
yeah, yeah, and I think it's definitely going to be very interesting to the audience as well. Well, until then, until next time, Jimmy, we will see you then.
All right, see you later, man. Appreciate it, Fernando.
All right, that was